and welcome to mathematics class. In our previous class, we started a new topic, which is matrices and determinants. Matrices and determinants. And in the previous class, we are able to define what matrix is. We are also able to perform basic operation on matrix, which is addition of matrix, subtraction of matrix, multiplication of matrix. So we're able to do those three outline: the addition of a matrix, subtraction of a matrix, and multiplication of a matrix. So today we are going to be taking another subtopic under the topic matrix and determinants. And today we are going to be considering determinant of a matrix. Determinant of a matrix. Determinant of a matrix. In our previous video, we also discussed of the hints and the tricks to know whether you can multiply two matrices or not. So if perhaps you are not chance to join the class the last time you had mathematics, you can do well to visit the A1 Tutor channel on YouTube and watch the video in details. Watch the video in details. Do not forget, you can subscribe. You can subscribe to the YouTube channel so you have notifications of our videos as we upload them. So let's get to today's business. We are working on determinant of matrix. Determinant of matrix. Determinant. Determinant of matrix. Determinant of matrix. Now, before we can actually go deep into this topic, determinant of matrix, there are some things you need to understand or to know. Now, we can only find the determinant of a square matrix. What is a square matrix? A square matrix, a square matrix is a type of matrix, is a type of matrix that has the same number of row and column, that has the same number of row and column. So a type of matrix that have the same number of row and column is said to be a square matrix. It's said to be a square matrix. So for example, if matrix A is given to be A, B, C, D, close the matrix. This is a square matrix because we have 1, 2, 1, 2. So we have to name it as row times column. And this represents your row. We have 2 rows by 2 columns. This represents your column. So that is 2 by 2 matrix. So this is a square matrix because it can be expressed as 2 raised to power 2. That is why we call it a square matrix. So a square matrix is a matrix that has the same number of row and the same number of column. We can also have a square matrix of 3 by 3. Let's say we have this matrix 1, 2, 3, 4, 5, 6, 7, 8, and 9. We have how many rows in this? We have 1, 2, 3. So that is 3 by the numbers of column 1, 2, 3. We also have 3. And this is the same as 3 square. So the square here, give it the name square matrix. Square matrix. So you can suggest of so many square matrices that we have. We have 2 by 2 matrix. We have 3 by 3 matrix. We have 4 by 4 matrix. we have 5 by 5 matrix, and so on and so forth. If it has the same number of row and the same number of column, it is called a square matrix. So in determinant of a matrix, we can only solve for the determinant of square matrices. So if I don't have a square matrix and I'm asked to find the determinant, the answer is undefined. If I have a matrix of this type, let's say we have a 3 by 2 matrix, a 3 by 2 matrix. Now, this type of matrix is going to be 1, 2, 3, 3 rows multiplied by 1, 2, 2 columns. So this is a 3 by 2 matrix, and it's not a square matrix. So if you are given that kind of matrix and you are asked to find the determinant, of course, you check the options and you select undefined. That is, we cannot solve the determinant of a matrix that is not a square matrix. So 3 by 2 matrix is not a square matrix. Example of square matrix is 2 by 2, 3 by 3, 4 by 4, 5 by 5, and 6 by 6, and so on and so forth. So if I have a 3 by 2 matrix, I cannot solve the determinant. So there's no need of me to stress myself going on to solve anything. The answer will just be undefined. But if it is a square matrix, of course, we can solve it. So let's see how we can solve the determinant of a 2 by 2 matrix. A 2 by 2 matrix. A 2 by 2 matrix. Let's see how we can solve the determinant of a 2 by 2 matrix. 2 by 2 matrix. So if I'm given a question to find the determinant, the word determinant can be symbolized by det, det. Then also it can be symbolized by, let's say we are given matrix A, 1, 2, 3, 2, and we are asked to find the determinant of matrix A. So I will say det A, that's determinant of A, or I can write it this way. This also means determinant of A, or we write it this way, determinant of A. So these are the three ways you can write determinant. Write it like this, or this is the second way of writing the determinant, and this is the third way of writing the determinant. So all these symbols symbolize determinant of a matrix, symbolize determinant of a matrix. Now let's see how we can solve a question on it by taking the concept of the 2 by 2 determinant of matrix. I have matrix A to be equals to A, B, C, D, and I'm asked to find the determinant of this matrix. You need to first understand that this matrix has two diagonals. This is the first diagonal, and we call it the major diagonal. It is called the major diagonal. While the other one is called the minor diagonal. This is called the minor. It's called the minor diagonal. So we have the major diagonal and the minor diagonal. And those two are going to be used to solve for the determinant of a 2 by 2 matrix. Take note, in the formula of the determinant of a matrix, there's always a natural minus. That is under 2 by 2, there's always a natural minus. So to get a determinant of this is going to be the product of the major diagonal. Product means multiplication. Products means multiplication. So meaning that the determinant det of A is equals to product of A and B, that is A times D, the major diagonal, A times D minus, open the brackets, down the minor diagonal. which is C times B. C times B. So that will give us AD minus CB. So this is the formula to solve for the determinant of a matrix. We are using alphabets, and that is why we don't have a specific value. Now, if you are going to be using a number in the matrix box, we are going to have a specific value. Let's try this question with that. We have matrix 1, 0, 2, 1, and we are asked to find the determinant of matrix B. Let's make use of B. Matrix B determinant equals to the product of the major diagonal, that is 1 times 1. So I have in bracket 1 times 1 minus product of the minor diagonal, which is 2 and 0. So that will give me 2 times 0. So to simplify this, I'm going to have 1 times 1. 1 times 1 will give us 1 minus 2 times 0 is what? 0. Subtracting 0 from 1, the answer is 1. So the determinant of this given matrix B, the determinant of matrix B is equals to 1. The determinant of matrix B is equals to 1. The determinant of matrix B is equals to 1. I believe that is clear to us. If yes, please kindly signify. We are moving on to the next. We'll be taking another example again under determinants of 2 by 2 matrix. 2 by 2 matrix. Okay, let's take one more on that note of 2 by 2 matrix. Permit me to wipe the board. Am I free to wipe the board? If yes, please signify.
10 minutes into his first appearance.
Okay, so let's take another question on determinant of 2 by 2 matrix. A question on determinant of 2 by 2 matrix. If matrix D, if matrix D is equals to matrix D is equals to 2, 6 minus 1, 4. Find determinant of D, which is D modulus. So find the determinant of what? D. This is the matrix given to us. If you are asked to find the determinant of this, we are still going to use the approach we use at the concept, multiplying the major diagonal minus the minor diagonal. The major diagonal in this is 2 and 4. So solution will be the determinant of D is equals to 4 times 2. That is the major diagonal minus brackets the minor diagonal, which is minus 1 and 6. That is minus 1 multiplied by 6. And when you simplify this, 4 times 2, 4 times 2, that will be 8, minus, multiply minus 1 times 6. That should give us minus 6. We go ahead to open the bracket by multiplying the sign, minus times minus, which is plus. Now, why did I say minus times minus? Consider your bracket to be multiplication. So we have minus times minus. Minus times minus, that will give us plus. So we're going to have 8 plus 6, and that will give us 14. So the determinant of the given matrix is 14. The determinant of the given matrix is 14. Question 3. Let's take another one. Given that question 3, given that matrix X is equals to 3, 8, 6, and 16. Close the matrix. Find determinant of X. Find the determinant of X. Still the same procedure. You need to identify the major diagonal and the minor diagonal. 3, 8, 6, 16. The major diagonal is 3 and 16, while the minor diagonal 6 and 8. So we have this to be minor diagonal and this to be the major diagonal. This is the major diagonal. So the determinant of X is the product of the major diagonal minus the product of the minor diagonal. So the major diagonal is 16 times 3 minus the minor diagonal is 8 times 6, close the bracket, multiply 16 by 3, that should be 48. 48 minus 8 times 6, multiplying 8 times 6, that is also 48. 8 times 6 is also 48. So taking the subtraction of this, the determinant of X is 0. The determinant of X is 0. So this is how we solve for the determinant of a 2 by 2 matrix. For a determinant of a 2 by 2 matrix. The determinant of a 2 by 2 matrix. So I want you also to solve this and drop your response in the comment section. If you are following us on YouTube, do well to drop your response in the comment section. Given that y is equals to 2, 2, 3, 4, find the determinant. Find the determinant of y. So solve this and drop your answer in the comment section. We'll be expecting your response in the comment section. Now let's go on to the next one, which is the determinant of 3 by 3 matrix. Now we've done that of 2 by 2. Now we want to consider the determinant of a 3 by 3 matrix. The determinant of a 3 by 3 matrix. The determinant of a 3 by 3 matrix is also simple to solve. I want you to follow me attentively. Determinant of a 3 by 3 matrix. Do not forget this is an evaluation question for you. You need to solve this and drop your response in the comment section or via the chat box. Permit me to wipe the board as we take the determinant of a 3 by 3 matrix. The determinant of a 3 by 3 matrix. 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 Let's first understand the concept of the 3 by 3 matrix. How do we use 3 by 3 matrix to solve for determinants? We have A, B, C, D, E, F, G, H, then I. This is a 3 by 3 matrix. And we want to find the determinant of this 3 by 3 matrix. You first need to give a sign to the first row. This is the first row. So give a sign to it, plus, alternate it to minus, then plus. So what we are doing is that the sign starts with plus, minus, plus, minus, plus, minus, plus, minus, plus, minus. Or you might decide to have your own as minus, plus, minus, plus, minus. So this sign is what we are going to use in solving for the determinant. In solving for the determinant. So to do that, we need to be very, very careful and follow the way we are solving it. So I need to go for the first value, that's plus A, circle plus A, determinant equals to plus A. Afterward, you're going to cross every value that is intersecting with A, intersecting with A. This will be crossed out because it is intersecting with A. This will be crossed out. Then you'll be having left E, F, I, H. E, F, I, H. Now we have to take the next one also. The next one, we have A, B, C, D, E, F, G, H, I. Still the same sign, plus, minus, plus. And this time around, I'm going to move to the next one, which is minus B. Minus B. So when you circle minus B, that means you have the determinant to be minus B. Then cross out the value that intersects with B. A and C, they are on the same line with B. Then E and H are also on the same line with what? B. So we have left with us D, F, G, I. So we have D, F, G, I. So that is for what? B. Then we'll go ahead again to do the same thing for C. So if I'm going to be selecting plus C now, plus C, I'll have plus C here. Now we need to cancel out the value related or the alphabet related to C on the vertical and the horizontal. Already the horizontal has been cancelled, but the vertical has not been cancelled. So we have done that, and we are left with D, E, G, and H. So we have D, E, G, and H. So these are the values that we have for plus C. Now all these will serve as the way out to get the determinant of a 3 by 3 matrix. It will serve as the way out to get the determinant of a 3 by 3 matrix. Let's take a numerical example to explain that. Example of 3 by 3 matrix. Example of 3 by 3 matrix. So we have given that matrix A is equals to 0, 1, 0, 3, 2, 1, 7, 8, 0, 5, 4. And you're asked to find the determinant of A. We need to first give signs to this question by having plus as the first one. The next one that we alternate is minus, then we still have plus. It continues like that. All right. So I need to identify each of these first row. We have plus 0. That is plus 0. And when you cancel where the row where 0 is, you cancel this, and you cancel this as the column. So we'll be having left 7, 8, 5, and 4. So the next one is minus 3. Minus 3. So we have minus 3 outside. Then trying to cancel this, where you have minus 3, this will go, and this will go. We'll be left with 1804. One eight zero four. 1804. Now let's go ahead to find the what? The determinant of this. The determinant of this. We are left also with plus 2. So plus 2 should give us plus 2. And we have, this is crossed out. This is crossed out. We have 1, 7. 1, 7. So we have 1, 7, 0, 5. 0, 5. So we need to okay, so I've written the 5 very well. Now let's solve this. I believe you get the way we are bringing up this value. It has to do with you identifying the first row with a sign, as we have here, plus 0, then cross any arrangement that has to do with 0. Okay, so let's go ahead. Multiplying this. This is another 2 by 2 matrix. This is another 2 by 2 matrix. Another 2 by 2 matrix. So we have the determinant of A to be equals to 0 in brackets, the major diagonal minus the minor diagonal. Major is 7 times 4 minus the minor diagonal is 5 times 8. 5 times 8. That is 0 multiplied by the bracket is 0 minus 8 multiplied by 5. 8 multiplied by 5, that is 40. And when you subtract this, we're going to have minus 40 as the LCM. We're going to have minus 40 as the LCM. So the LCM the determinant rather of this question is 40, but it's going to have a minus, so it's going to be minus 40. Let me come again. I said you have to put the sign first. After putting the sign, you need to identify the question. So if this is my major diagonal, what I did was that I multiplied 7 times 4, which is here, minor diagonal, that is 8 times 4, which is what also presented here. And that's not all. That's not all. You still need to proceed with the next one. So this is gone. We have to do this. That's plus 3 in bracket. The major diagonal, 1 times 4 is 4. The minor diagonal, 0 times 8 is 0. 0 times 8 is 0 plus 2. The major diagonal is 1 and 5. That's 1 times 5 into another bracket. The minor is 0 times 7. 0 times 7. So let's go ahead to solve this. Of course, 0 multiply everything here. We have 0 minus 5 times 8. 5 times 8 is 40. And we have the next one to be plus 3 in bracket. Subtracting 0 from 4. Subtracting 0 from 4. We have 4. Then also plus 3 times 4. And next we have here, there will be a minus between these. Take note, as well as a minus. So we have plus 2 in bracket, plus 2 in brackets. So plus 2 in bracket, we need to multiply 4 times 5. 4 times 5. That should give me 20 minus 7 times 0. That is 0. Close the bracket. We have minus 40. That is taking away 40 from 0 is minus 40 plus multiplying 3 and 4. That is 12 plus 2 in brackets. Subtracting 0 from 20. Subtracting 0 from 20 is still 20. And when you simplify this, you have minus 40. Writing it from the first value, minus 40 plus 12 plus 2. So that will give us 2 times 20. That should give us 40. So we have minus 40 cancel plus 40. Minus 40 cancel plus 40. And we are going to have the final answer to be 12. That's the only value we have left. We have 12 to be the determinant of this question. The determinant of this question is 12. The determinant is 12. Let's take one more question on the determinant of 3 by 3 again. Another example on the determinant of 3 by 3. Please do well to listen attentively. Let's wipe our board and take another one. Determinant of 3 by 3 matrix is what we are still working on. So we want to take more questions on that. More questions. Let's say we are given the matrix. We are given the matrix A to be equals to 2, 3, minus 1, 1, 0, 2, 3, 2, 3 minus 2, and we have 3. And we are asked to find the determinant of this expression. The determinant of this expression, first thing is to put a sign plus, minus, plus. So you start with the first one, which is plus 2, determinant equals to plus 2. Now we need to check where plus 2 is crossing with the value of, where plus 2 is crossing with the value of the row here, and the column is this. So we're going to write the remaining one we have that are not crossed out. That is this portion. This portion is going to be 0, 2, 2, 3. So that is for the first one, which is plus 2. Now we have the next one, minus 3. So we have minus 3, minus 3. Now if I take minus 3, once we have picked minus 3, we need to check where all this value is crossing. So the value is crossing at this vertical, and also is crossing at these 3. So the value left is 1. The value left is this 1, 2, 3, and 3. So we have 1, 2, 3, and 3. So this is the way we go about solving the determinant of a 3 by 3 matrix. And lastly, we are going to have the plus sign, which is plus 1 in brackets or in matrix shape. We are going to consider where plus 1 crosses the value at the row and at the denominator. So we have minus 3 here. So we can proceed for that of 1. What are the value? This is 5 before, and this is 2. So what are the value that cross with the value 1? We have this row and this denominator. So we'll be having the matrix form 1, 5, 3, 1, 5, 3, 2, 3, 2, which is now simplified as multiplying the major diagonal, which is 0 times 3, open the brackets, which is going to have a minus, open the brackets, 2 multiplied by 2, which is the minor. The major is 3 multiplied by 0. And the minor is 2 multiplied by 2. We have the next one. Don't forget there's a plus 2 in front of it. We have minus 3, open there, matrix. Now we have to take the multiplication also like we did the other time. The major rather, but minus the minor. So the major is 3 minus the minor is 6. So we have plus, we continue. This is going to be plus 1 in brackets, this multiplied by this, that is 2 minus this multiplied by this, that is 35. Sorry, that is 15. 5 multiplied by 3, that should be 15. 15. So go ahead to simplify. Plus 2, open a bracket, 3 times 0 is 0, minus 2 times 2 is 4. Minus 3, open the matrix form. Subtracting 6 from 3, the answer will be minus 3. And we have plus 1. Subtracting 15 from 2, that is minus 13. And when you simplify this, you have plus 2 into bracket minus 4, minus 3 into bracket minus 3, plus 1 into bracket minus 3. So we're having minus 13. Simplify this, we are going to have minus 2. We have 2 multiplied by minus 4. That is minus 8. We are still solving for the determinant. Minus 8. And minus 3 multiplied by minus 3. That will give us 9. Because the minus times minus is going to give us a plus. The minus times a minus, minus times minus is going to give us a plus. So we have minus 8 plus 9. Now also 1 multiplied by minus 13, that is minus 13. So we have minus 8 minus 13 plus 9. Minus 8 minus 13 plus 9. The answer is minus 12, which implies that the determinant of this particular matrix is minus 12. The determinant of this particular matrix is minus 12. I believe it's clear to us how to solve for the determinant of a 3 by 3 matrix. I believe that is clear to us how to solve for the determinant of a 3 by 3 matrix. You have to first identify the plus minus sign. After that, you take each of the sign with the number that belongs to it and cross out where the number belongs, either the row or the column, then write out the remaining value. Write out the remaining value. So this is how we solve determinant of 3 matrix. So if this is clear to us, please, let's kindly signify. We are moving on to the last aspect of this topic, which is the inverse of a 2 by 2 matrix. If this determinant of 3 by 3 is clear to us, kindly signify with a thumbs up. Kindly signify if the 3 by 3 matrix, the determinant of a 3 by 3 matrix is clear to you. Signify. We are moving on to the last outline of this topic, which is the inverse of a matrix. Inverse of a matrix. Okay, now let's take the inverse of the matrix. But before that, let's take a pause and address our audience, our followers on YouTube. If you are coming across this video for the first time, or this is the first time that you are watching A1 tutor video, please do well to click on the subscribe buttons. So you are going to have access to notifications as we upload our videos. And also, while you are watching the video, if you have questions concerning what you're actually going through, drop your question, drop your comments in the comment section on the YouTube page. Do well to drop your question in the comments section so we can actually go through it and give you a feedback on it. So let's take the next one we are talking about. We'll be talking about the inverse of a 2 by 2 matrix. The inverse of a 2 by 2 matrix. The inverse of a 2 by 2 matrix. Permit me to wipe the board. The inverse of a 2 by 2 matrix. The inverse of 2 by 2 matrix. And there are steps to actually follow when doing the inverse of a 2 by 2 matrix. I'm going to share those steps with us, and we are going to work with those steps accordingly. The steps needed in solving a 2 by 2 matrix. The step needed to solve a 2 by 2 matrix. Step required in solving the inverse of a 2 by 2 matrix. The inverse of a 2 by 2 matrix. So I'm going to share us with the hints on how to do that. Okay, so this is the note. We have, this is what we want to focus on, finding the inverse of a 2 by 2 matrix. Step 1 says swap A and D. Let's say we have matrix A to be equals to A, B, C, D. To get your inverse, step 1 is swap A and B, swap A and B, swap A and D. So if I'm swapping A and D, that means this will come to this place and this will go to the other side. So that is what we mean by swapping, swapping A and B. Step 2, change the sign, change the sign, change the sign of B and C. Change the sign of B and C. And the next step is obtain the determinant. Obtain the determinant. Option 4 is to divide the matrix by the determinant. Divide the matrix obtained by the determinant. Divide the matrix by the determinant. So we are going to solve this one with the alphabet here using these steps. Option A says, the first step says swap A and D. So if I'm swapping this, I'll be having D here. I'll be having A here. That is swapping. So we've done the swapping. They said the next step is to change the sign of B and C. The sign before was positive, positive. So if I'm going to change it, I'm going to have minus C and also minus B. So I've done the first step and the second step. After swapping, we have to change the sign of C and the sign of B. First step and second step done. The next one is to obtain the determinant. And what determinant are you obtaining? The determinant of this particular matrix that was given in the question. Determinant of this is going to be A. Determinant of A equals to AB minus BC. that is multiplying this, that is the major, minus the what? Minor. So this will be the determinant. Now, lastly, you have to divide the matrix you obtain by the determinant. This is the matrix obtained, and we are going to be dividing that matrix obtained by the determinant. So we have the final answer to be D minus B minus C A, all divided by the determinant, which is AB minus, which is AD, rather, AD, it should be AD minus BC. And this is the inverse of a matrix, inverse of 2 by 2 matrix. So the alphabet we are using is just for us to understand how to solve it. Now we are going to take a question that has number, a matrix that has number, and we are going to solve for the inverse of that matrix. The UTME exams focus mostly on the inverse of 2 by 2 matrix. So I will want you all to follow attentively and get it right, so that when questions comes on it, you can solve it accurately. Okay, let's take the question on inverse of 2 by 2 matrix using a numerical question. Given that A equals to 2, 6 minus 2, 4. Find A inverse. This is another way that inverse can be written, using it as raised to power minus 1, or it will be written in full, inverse of A. Okay, inverse of A. Now let's solve this together. Step 1 is to swap these numbers. So if I swap it, I'm going to have 4 here, I'm going to have 2 here. Step 2 is to change the sign of this number, which is minus 2, change the sign, and change the sign of what? 6 also. If I change the sign of minus 2 will now change to plus 2. So we have 2 here, and this was plus before, plus 6. When you change the sign, you have minus 6. Minus 6. We are done with this. Now let's get the what? The determinant of this matrix. The determinant of this matrix, the given matrix in the question, 2, 6 minus 2, 4. Getting the determinant of the matrix is this multiplied by this, that is 4 times 2 will give us 8 minus 2 times this, that will give us minus 12, which is 8 minus times minus is plus. We have plus 12. And when you add this together, the answer is 20. So the determinant of the given question is 20. So inverse of A is now equals to the matrix I obtained. This matrix 4 minus 6, 2 and 2, close the bracket, divided by determinant. Determinant is 20. So we'll be having 4 over 20 inside the matrix minus 6 over 20. We'll be having 2 over 20 and also 2 over 20. So if you can reduce this, you can go ahead to reduce it. 4 over 20 is the same thing as 1 over 5. That is 4 divided by 4 is 1, and 20 divided by 4 is 5. This also we can reduce it. 2 in 6 is minus 3, and 2 in 20 is 10. The next one we have 2 over 20, which is 1 over 10, and another 2 over 20, which is 1 over 10. So the matrix obtained is what we have here. This is the inverse of A. The inverse of matrix of what? A. Matrix A. The inverse of matrix A is 1 over 5 minus 3 over 10, 1 over 10, 1 over 10. So that is the inverse of matrix A. I'm going to drop a question for us, and we are going to solve that and drop our answers in the comment section on YouTube. Permit me to wipe the board, or you can quickly take this down by taking a screenshot so we can have the question that we are going to use as brainstorming question. And I want you to ensure you solve the question and drop your answer in the comment section on YouTube. So let's have the question. If B is equals to minus 1, 2, 4, minus 4, 3, find B inverse. So you are asked to find the inverse of matrix B. Following the step that I gave you, the first step is to swap this, this. And the next step is to change the sign of this and this. And then you find the what? The determinant of the original question. That is the original matrix given to you. So that is what you're going to do for me, and drop your answer on the comment section. Drop your answer in the comment section on YouTube. So today we've been able to discuss the determinant of 2 by 2 matrix, the determinant of 3 by 3 matrix, and I said we can only solve for a square matrix. The determinant of a matrix, we can only go ahead to solve a matrix that has a type called the square matrix. 2 by 2 matrix can be solved, the determinant can be solved. 3 by 3 matrix, the determinant can be solved. 4 by 4 matrix, the determinant can be solved. So we talked about 2 by 2 matrix and 3 by 3 matrix, and now we rounded up with the inverse of 2 by 2 matrix, So if you want to have a detailed video, you want to have a detailed knowledge on this matrix as a topic, visit the A1 Tutor app and search under SS3 the topic matrix and determinants. Is there. You can do well to watch there and increase the knowledge of matrices and determinant that you have. And also, do not just watch the video, ensure you practice UTME question on the app A1 Tutor. Don't forget, this question is for us. You have to solve and drop your answer in the comments section, and drop your answer in the comments section on YouTube. So we're expecting you to solve this question and drop your comment section on the YouTube page of A1 Tutor. So when you search this, you're going to see our page on the YouTube. So solve this question and drop your answer in the comment section. Thank you for your time today. Tomorrow is another time. We are going to continue with this topic by taking UTME questions that are basically on matrix and determinant. We'll be solving a lot of UTME questions that have to do with matrix and determinant. So ensure you are also present tomorrow. There are 2 classes that I'll be holding tomorrow. Starting by noon, we have the first class, and by 1, the second class will commence. Ensure you join the class and you do not miss any of the live session. Thank you and see you tomorrow. Bye.